Okay, so this is back on track with our train one. So we've got a train that is accelerating. So we have its acceleration, and the it starts by saying, given this train is stationary when t equals 0, show that the train's velocity at time t is given by this. So remember, we're going from acceleration back to velocity, which means we are integrating, aren't we? If we were going from velocity to acceleration, we differentiate. So we just got to get the direction right. So we have to integrate that to find that, essentially. And we're going to have this bit of information which is going to help us find C. Okay, so bear that in mind. We'll tuck that away for a little bit. Okay, so it kind of gives us a clue, doesn't it? Because if we forgot that this is essentially a simplified version of 1 over x, well, they've got, and if we integrate 1 over x, we end up getting ln of x. This is the situation where we've got 1 over f of x dx. And what happens is we go ln of f of x divided by the derivative. Okay. So what we did before is if we had a log function, if we had f of x equal to ln of, say, 2x, then the derivative was, remember, the derivative of the top function, 2, divided by the bottom function, 2x. Okay, so here we've got a similar thing. So we're going in reverse order. We've got this on the bottom, and we multiplied by the derivative of this. So now we're going to have to do the divide by the derivative of my top function. Okay, so let's start. So the integral of 1 over 0.2t plus 2 dt is my variable, is going to be equal to, okay, so here's my function. So it's going to be the natural log of my inside function divided by the derivative of the inside function. So the derivative of that is just 0.2t, so it will be 0.2, okay, plus c. Now 0.2 dividing by 0.2 is the same as multiplying by 5. Okay, look, I can check that. So 1 divided by 0.2, 0.2, 1 divided by 0.2 is 5, yeah? Because it's dividing by 20%. So this is the same as 5 ln 0.2t plus 2 plus c. Okay, so I'm at the point where I'm like, sweet, nearly there. But there's some weird stuff going on here, because I've got 0.1t plus 1, I've got 0.2t plus 2. So there's a factor in there that is not quite working out, is it? So at this stage, I'm going to go, I want that to look more like that. There's obviously a factor of 2 that's been taken out. So I'm going to do that now. So 5 bracket ln of 2, I'm left with 0.1t plus 1 plus c. Okay, so now I can use my log rules to realize that, well, my log rules say that ln of a times b is ln of a plus ln of b. So this is going to be 5, and I'll expand the 5 at the same time. ln 2, so 5 ln 2 plus 5 ln of this factor, 0.1t plus 1 plus c. Okay, so this bit here looks good. That's what I want, but there's some issues still, isn't there? So let's carry on now. Let's try and find out what C is. So this is the bit of information we need for this. Okay, so in fact, we've got symbology here. So V of 0, the train is stationary, which means 5 ln 2 plus 5 ln of 0.1 times 0 plus 1 plus c is equal to 0. Okay. Which means we have 5 ln 2. Now 5 ln 0.1 times 0 is 0. So I've got 5 ln 1. Now ln of 1, like natural log of 1, if you forget, plug it in, ln of 1 is 0. So that whole thing becomes 0. Plus c equals 0. So what that means is that c is equal to, if I bring that over, negative 5 ln 2. Okay, so if I go back to my original function, which I got over here, this is v of t equals, so v of t equals, therefore v of t is equal to 5 ln 2 plus 5 ln 0.1 t plus 1 plus my c, which is negative 5 ln 2. And you'll see there we've got 5 ln 2 minus 5 ln 2. Cancel those guys out. Is equal to 5 ln 0.1 t plus 1 as required. That's what I'm after. Okay, done. Okay, my next question says, find out how far the train has travelled in the first 10 seconds of motion. So what I do know is that it has stopped, but it's when time is 0. So in the first 10 seconds is like it's starting from a place where it's moving. I guess I have to think about, or does it stop again within this time? Because it might, if it goes below the x-axis, I'm going to have to think about how that looks. So what I've done is I've just chucked it in my calculator. 5 ln of 0.1x plus 1. And I've gone, well, my window needs to be up until at least 10 seconds. So I've gone up to 15. And I've had a guess at minus 5 to 5. And from that I can see that yes, it is 0, 0, like it said, when time is 0, stationary. But from then on, it's always a positive function. So it kind of makes it easy for me. I can literally just go, well, what is the integral underneath this? This is how far, remember? How far, when we're looking at velocity, is the area underneath. Think about our Melbourne trip. The area underneath the line was how far the car travelled. So I can go, while I've got it in my calculator here already, I can go second calc 7 between 0 and 10, and it will fill it in and calculate it for me. Okay, 19.3 something. Okay, so I'm just going to go, and I'm going to write this 0, 10, 5 ln 0.1 t plus 1 dt is equal to 19.31. Okay, and that's for sig figs. And I'm going to say using GC. Okay, so it's important to write this and not just this, because if I stuff up on my calculator, I'm going to get probably a mark still to say, well, I recognize that this is this. Okay, I might even put, no change in direction on 0 t 10. Just to make my point, say, yeah, I have thought about this, and it didn't change direction.